used in the LAN. If I'm at 2.4 gigahertz, I want one that goes up to 3. The impedance needs to match. The VSWR rating should be as close to 1-to-1 as you possibly can get. You also want to make sure that it has a high isolation impedance. There's actually 2 reasons why this is important. First, a load on one of your output ports should not affect the output power on another output port of the same splitter. And second, if you've got a signal arriving on one port of the splitter, such as the received RF signal on an antenna, you want to make sure that it's directed to the input port rather than being directed to the other output port. So it is very important that the isolation impedance is set properly, and it needs to be identified before the radio frequency splitter is actually purchased. The power rating is also an issue. You want to make sure that we are focused on the maximum power inputs. What this means is that we can only go so high as what our maximum power limitation is going to be is set forth by the FCC. You want to make sure that your power rating can be part of that system and still comply. Connector types need to match as well. And we also need to make sure that we have a calibration report from the manufacturer. This will normally tell us what the insertion loss is, the frequency response through each of the connectors, and always having this information at our disposal is great, especially when we're dealing with a complex wireless LAN. Want to make sure that our mounting is appropriate. With mounting, usually it's just normally putting screws through flange plates into whatever surface on which the splitter is mounted. But some models will actually come with a pole mounting component with U-bolts, which allow you to obviously attach this to a certain type of a mounting pole or mounting bracket, even on a tower. Now, depending upon the manufacturer, some splitters will be weatherproof, meaning they can be outside. Some of them are not, meaning they can only be used inside. So it's a good idea to investigate this before you actually purchase a splitter. And finally, you want to make sure that your DC voltage passing is up to par. Some RF splitters have the option of passing the required DC voltage to all output ports in parallel. And this feature can be very helpful when there are other radio frequency amplifiers with powered internal circuitry that require DC voltage, which originates from a DC voltage injector in a wiring closet. And this, of course, can be something that an RF splitter can carry on down the radio frequency link. So you need to make sure that you specify this and identify before you actually purchase it from a manufacturer. So now we've got all these components of a radio frequency circuit. Now we actually have to put them all together with RF connectors and RF cables. RF connectors, very specifically types of connections that are used to connect cables to cables or devices to devices in a radio frequency network. Now there are a variety of types of connectors. Traditionally the N-type, F-type, SMA, BMC, or TNC connectors or derivatives have been used for almost all connections on wireless LANs. But in 1994, the FCC and now the DOC, which is called Industry Canada at this time, ruled that connectors for use with wireless LAN devices should be proprietary between manufacturers. So for this reason, many variations on each connector type exist. A couple of things to do when choosing a connector. 5 separate things. The first component is that you should always match the impedance of all of the other wireless LAN components. Once again, generally 50 ohms. This is normally not a problem since even when you purchase like connectors with different impedances, they will not properly fit together because of center pin sizing. So impedance is typically something that's very easy to adhere to. The second thing is to know how much insertion loss is going to be on each connector that's inserted into the signal path. The amount of loss which is caused obviously factors into your overall calculations for signal strength required and the distance allowed in your radio frequency network. You also want to know your upper frequency limit, the frequency response. This point is very important as you want to make sure that whatever the frequency limit is, that it will definitely work for your wireless LAN. If you're at 2.4 gigahertz now and all you buy is a connector rated as high as 3 gigahertz, then obviously if you go to an 802.11g, which is using the 5 gigahertz LAN, it's obviously not going to work and you'll have to replace all of your connectors. So make sure that the upper frequency limit is appropriate for whatever your current situation is and whatever you hope to advance to in the future. Also beware of bad quality connectors. Make sure that you do buy your connectors from a reputable company. You don't want to buy cheap connectors just because they're cheap. You want to make sure that you buy the connector that is going to last, as obviously the impedance gets off, something happens to the connector, it can disrupt your entire radio frequency circuit. And finally, make sure that you do know the connector configuration that you require, whether it's an N-type, F-type, SMA, BNC, or TNC connector type. Remember that you need to know the configuration of the connector and match them appropriately. The male and female connectors have to be, of course, properly sized and fitted, and you have to make sure that it does complete the circuit in your radio frequency network. The other major factor is the radio frequency cables that you use. You're going to have to provide the same level of specification and planning that you would if you were speccing out a brand new network backbone. You have to choose the proper cables for connecting antennas to access points or connecting to wireless bridges. Now, there are some criteria that you want to follow when you actually choose radio frequency cables. First and foremost, because cables will introduce loss into a wireless LAN, always make sure to use the shortest cable length that you can possibly use. If you can purchase pre-cut lengths of cable with pre-installed connectors, you're also going to have better luck because this will minimize the possibility of bad connections or possibly bad fittings that an individual might do. These cables can actually be certified by a trained individual to make sure that they are, of course, perfect for the impedance and so forth at both ends of the cable. You also want to try to look for the lowest loss cable available at a particular price range. The lower the loss, the more expensive the cable is going to be. So when you're looking at cables and they look identical, and you're wondering why is one of them almost 3 times as much as another, the reason is because it's rated for loss in decibels per 100 feet. It's a higher quality cable, definitely going to have lower loss, definitely going to be more expensive. Once again, make sure that you match impedance through and through, both ends of the cable. Also make sure that your frequency response is maxed out for what you expect. So if you're planning on going to a 5 gigahertz wireless LAN in the future, make sure that the frequency response of your radio frequency cable will go that high. And also be aware of your connectors. When you have an extension cable which actually has to connect an access point to an antenna that's far away, a lot of times you have to actually use an extension cable between the access point and the antenna itself. And be aware that each connector will drop your frequency response approximately 0.25 decibels, and cable loss can be very significant depending upon what type of cable that you use. You might decide, instead of having an extension radio frequency cable going to the antenna, that you actually move the access point closer to the antenna with a longer Cat5 cable. That, of course, is going to reduce the overall frequency response drop by having too long of an extension cable and too many connectors. One thing to also realize, RG58 cables should never be used for extension cables because it has incredibly bad frequency response. Something like LMR or Helix or some other appropriate very high frequency cable should always be used for extensions so that you don't lose that gain when you have to connect to your antenna. The last component which you may have to use is known as a pigtail adapter cable. Now, this is used to connect cables that do have industry standard connectors to a manufacturer's wireless LAN equipment. Remember that pigtails are used to adapt the proprietary cables. Remember that there is a specification that identifies that vendors have to use a proprietary connection for all of their LAN devices, and pigtails are used to adapt proprietary connectors to an industry standard connector like an N-type or SMA. One end of the pigtail is going to be proprietary, while the other end will be industry standard. Now remember, this is the DOC and FCC regulation in 1994 that says that all connectors that are manufactured after June 23rd of 1994 must be manufactured proprietary. This 1994 rule was really intended to discourage the use of amplifiers and high-gain antennas or other means of actually increasing the RF radiation significantly where it would exceed the FCC requirements. The rules are further intended to discourage what are known as homebrew systems, which are installed by inexperienced individuals which either accidentally or sometimes intentionally do not comply with the FCC regulations for use in the ISM band. Now, since this rule was enacted, keep in mind, consumers have had to obtain proprietary connectors from manufacturers to be able to connect to an industry standard connector. The third-party manufacturers have begun to make custom cables, and they call them pigtails, and that's when you'll have to use one. They do sell them very inexpensively on the open market, however. But keep in mind that the FCC's CFR 15.204 does not allow any homebrew systems of any kind that are not certified. All systems must be certified, and a system is defined as an intentional radiator, an antenna, and everything in between. So those individuals that use security utilities such as NetStumbler with a Pringles can or a similar antenna are in direct violation of this FCC regulation and are subject to fines exceeding $1 million.